Taking a look at the problem 2 sum number 2 input array is sorted. So given an one indexed array of integer numbers that is already sorted in non-decreasing order, find two numbers such that they can add up to a specific target number. So let's just look immediately at an example. So we have a list of numbers 2, 7, 11, 15. The target is 9. So the output is index 1 and index 2. Note that they start from index 1. Okay, let's see. Yes, one indexed array. Okay, so let's look at this problem. Okay, so I'll write here a list. Let's take a different list. 2, 3, let's say 5, 7, 11. And let's have the target as 8. Okay, so we are beginning to look at the brute force of this. Okay, so we have all these patterns. The basic pattern, if we have an array, is simply to scan this array. So let's start with index 2. Okay, we need two numbers, so, and the second pointer would be here. So 2 plus 3 is 5, not good. So we are still with 2, and now the second index would be here. 2 plus 5 is 7, not good. So we are still here, and 2 plus 7 is already above, it's 9. So we can stop here. And next we move to the next number, 3. Okay, so we already were looking at 2 plus 3, so we can just start the second pointer from the next number. So 3 plus 5 is 8, and this looks good. The problem with this is that basically for each number, when we start, we would potentially need to scan all the numbers, and then for this number, we would potentially need to scan all the numbers, and for this number, we would potentially, which makes it for each number we have n possibilities, and we have n numbers, so it's n times n, which is n squared time complexity, which does not look good because the array is already sorted. Basically, the patterns that we already have in general in this kind of problems is that first we can scan the array, which we already did here. Scan it. We can sort the array, but it's already sorted. Okay, so this is already sorted. We are already scanning it. You can use the previously mentioned so far pattern, which just means that we have a moving aggregate. So if we had here anything like a sum of numbers, the sum of numbers so far, or the maximum number so far, then this might make sense, but because we don't have this, then this here does not make sense. We could use recursion. No reason to say it doesn't pop up that we need recursion because this does not seem too that complex. And we could do reverse scan. What does reverse scan means? This means that if you noticed previously that our pointers were moving from the left to the right because we had the first pointer here and the second pointer here, in the reverse scan, one pointer is at the beginning, is starting from left to right, and the other pointer is moving from the right to the left. Would this give us any advantage? So here we already see that the number 11 itself is already greater than 8. This means that if we had here additional numbers who are larger than 8, then we could just get rid of them, right? Now, if we take a look, let's say, at this next number here, so we got rid of this number, and now we move to the right pointer. We are now at the reverse scan pattern. Reverse scan pattern. So now we move our pointer to the second one from the right, and we see again that the sum of them is 9, so it's larger than 8. Does this mean we need to move the left pointer to the right? No, because if we move the left pointer here to the right, we would get even a larger number, 3 plus 7, 10. So there is no sense to moving the left pointer to the right. There is only sense to reduce the number, because we had 2 plus 7, which is 9. So we reduce it to here. And now, because we reduced this pointer to here, then 2 plus 5, is it larger or smaller than 8? It's actually smaller, because it's 7, so there is no reason to move the right pointer to the left, because if we remove it to the left, we would only get a smaller number. So now we need to move the left pointer to the right. And now here we actually get a number. So we see that the reverse scan pattern here is actually giving us a great choice, and the intuition is that we need to find a balance in between two numbers, the balance that would give us the right number, and it's already sorted. So the reverse scan is excellent here, great one. Whenever we see a sorted array, the reverse scan, which means one pointer from the left, one pointer from the right, could be a great potential to solving it. And now let's actually write the code. Okay, so we are going to have here our 2 pointers, so int. Let's just call them I and j. So I is starting from the left and j is starting from the right. The right is numbers dot length -1. This is the right side. And now, as long as the left pointer is smaller than the right pointer, because if it's beyond it, then we just didn't find the number. So as long as the left pointer is smaller than the right pointer, then let's calculate the current sum that we have, which is numbers I plus numbers j. Now let's check if the sum is smaller than target, and we need to move the left pointer to the right. So actually no need to waste really space here. Let's just move the left pointer to the right, and else if the sum is larger than the target, then we need to move to the left, which means j minus minus, and else, which means that the sum is equal to the target, we return the result, which is a new int, and because it's index plus 1, 0 plus 1 based, and we have I plus 1 and j plus 1, and this would not happen, but because we wanted to compile, we would return here a new empty array. And now let's try this. Obviously the hardest part was to come up with the actual solution, and coding it is much easier. Okay, so let's check this, and with this we have from the left to the right, we have also here a kind of a problem. Int I is 0, and actually here we need a comma, because we are initializing two numbers in Java, so we need a comma and not a semicolon. And let's submit it, see that it's working. So this was basically the two sum where we needed, because the array was sorted, then we had 2 pointers, one from the left and one from the right, which is a basic pattern when having a sorted array, and we need to find some balance, and the balance is this target in between the sum of the two numbers.